Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing. Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Pakuchezo Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area, matter and materials. The topic is atoms, and the subtopic is pure substances and elements. Now let's go through the lesson objectives together. So these are the goals we want to achieve by the end of the lesson. So at the end of the lesson, you should be able to define a pure substance, describe a pure substance, define an element, and explain that some elements exist as diatomic molecules, and also discuss that sometimes atoms of different elements react together chemically to form molecules of compounds. All this is sourced from your KEPS document on page 41. Now let's move on to pre-knowledge. So here we just remind each other of what we have learned in the past or in the previous lessons. Remember, in week 1 of grade 8, we were introduced to the periodic table of elements, and we also learned about the physical properties of materials. We have also learned about atoms, which are the building blocks of matter, as well as the subatomic particles of an atom. These are the particles that make up the atom. Now, there we also learned about the structure, or rather this is the general structure of an atom. Let's move on to today's baseline activity. So I'm going to read out the questions, then give you time to answer them. Then we will do the corrections together. So the first question reads, question number 1. How many subatomic particles are there in an atom? Name them. Label the diagram below. So you need to give labels for A, B, C, and D. And then number 3, define an element. Question number 4, the diagram below shows an element found in the periodic table. Draw a neutral atom of this element. All right, so take 5 minutes to do this activity. Then after 5 minutes, we will do the solutions together. Don't forget to send in any questions you may have and the solutions to this activity to the WhatsApp number that's at the bottom of the screen. If you can't see it, I'll read it for you. It's 079-578-2908. So see you after 5 minutes. Welcome back, learners. Now let's go through all the questions together as well as the solutions. So the first question read, how many subatomic particles are there in an atom, and then name them. So this is a two-part question. So first you need to tell us how many subatomic particles are there in an atom, and then name them. So how many are there? There are three. There are three. And the first one is electrons, protons, and neutrons. So those are the names of the three subatomic particles that are there in an atom. Now let's answer the second question. So in this question, we are required to label the diagram below. So the diagram below is that of an atom. So it's a general diagram of an atom. So we needed to label it. So let us label it together. The first one, that A that is an electron, C proton, right there with the plus sign in the middle, D next to the protons, or rather together on the same space with the protons is the neutrons, and that zone is the nucleus. That zone is the nucleus. Now let's answer the third question. Let's answer the third question. Define an element. Define an element. Right, so when we are defining elements, an element is a material that consists of only one kind of atom. It consists of only one kind of atoms. Then question number 4. The diagram below shows an element found on the periodic table. Draw a neutral atom of this element. So this element is found on the periodic table, and we are required to use the information we have been given to draw a neutral atom, of this element. So what do we know? We know that 7 is the atomic number. The atomic number tells you how many protons are found in the nucleus of this particular atom. Right, and in a neutral atom, the number of protons is equal to the number of electrons. So which means this atom has 7 electrons. Right, so in a neutral atom, so you need to read carefully, in a neutral atom, the number of protons is equal to the number of electrons. So we know that an atom of this element in a neutral state will have 7 protons and 7 electrons. So now to draw the atom, we need more information. We need to know how many neutrons there are, or how many neutrons this particular atom has. Now, to find out how many neutrons this particular atom has, we use this big number. Remember, we said this is the atomic mass number. So we use the big number, and we say atomic mass number minus atomic number. So we say 14 minus 7 to give us 7 neutrons. So now that we have all this information, we know how many electrons the atom will have, how many protons the atom will have, and how many neutrons the atom will have. Then we draw our atom. Now, where do we find, or where are we supposed to draw the protons? So we're supposed to draw the protons within this zone. This zone is called the nucleus, which is found in the center of an atom. So our key, according to our key, our protons are the orange circles that have the plus sign in the middle. Remember, plus sign means positively charged. So protons carry a positive charge. So to identify them, we will add a plus sign in the middle of the orange circle. And then our neutrons are represented by a green circle. There is no charge written inside that green circle. This is because our neutrons are neither positively charged nor negatively charged. And then we have our electrons. Our electrons have a minus sign inside the green circle. The minus sign tells us that our electrons are negatively charged. So within the nucleus, we are going to draw the protons and the neutrons, and then outside in the electron shell, that's where the electrons will be drawn. Right, so take 2 minutes to quickly copy down the solutions for this question, and then after 2 minutes, we will continue with our lesson. In your solutions and any questions that you may have to our WhatsApp line, which is 079-578-2908. Now let's continue with our lesson. So next we are going to tackle terminology. So these are the terms that we're going to be using throughout the lesson. So help us. Knowing what they mean or knowing them will help us to better understand our lesson today. So the first term is pure substance. Pure substance. This is a substance made up of one type of atom or molecule. The next term is periodic table. We've seen this one before. It is a classification system for elements which make up matter and materials. The next one is molecules. These are two or more atoms that are chemically bonded together. And then the last one is element, a material that consists of only one kind of atoms. One kind of atoms. So now let us begin our lesson. Pure substance. Remember, all matter is made up of tiny particles called atoms. Remember from our previous lesson. So I've made a little map. So matter can be subdivided into pure substance or pure substances and then a mixture of different substances. Now let's remind each other again. A pure substance is a substance made up of only one atom or molecule. When you hear one atom, I'm sure the word element comes to mind. And elements are pure substances. Now, pure substances can also be categorized. So under pure substances, we've got elements and we have compounds. Remember, elements are substances that are made up of only one type of atom. Now, elements, remember, each element also has its own
properties. Now, if we look at the element aluminium, we often come into contact with aluminium, especially when we're dealing with aluminium foil. So a sheet of aluminium foil is a pure substance. Why? Because it is purely made up of one element, and that element is aluminium. So an aluminium sheet is an example of a pure substance. There are no other substances in an aluminium sheet. So an aluminium sheet is a good example of a pure substance. And this particular pure substance is made up of an element, a single element, and that single element is aluminium. Okay, now we have established that an element is a what? It is a pure substance. Why? Because it is made up of only one type of atom. So if we look at other elements such as hydrogen, carbon, sodium, and oxygen. So if we only have hydrogen atoms on their own, then that becomes a pure substance. If you've only got a substance made of carbon alone, then that is a pure substance. If we have a substance or a piece of matter made of sodium alone, then that is a pure substance. If we have a gas that consists of oxygen alone, then that is a pure substance. And I'd like to remind you that elements cannot be changed into another element, either is it by physical means or by chemical means. So you cannot change hydrogen into carbon, you cannot change carbon into sodium, and you certainly cannot change oxygen into hydrogen, whether you're using physical means or you're using chemical means. Oxygen atoms will always be oxygen atoms, and they cannot be changed into something else. Now, remember, elements have atoms, or rather, elements have atoms, and they contain protons, neutrons, and electrons. So an element, so the name of the element is hydrogen, right? And hydrogen has atoms, and those atoms have subatomic particles. And what are they? They are protons, they are neutrons, and they are electrons. Those are the subatomic particles. Now, all known elements are listed on the periodic table of elements. All the known elements, or all the elements that we know today or that scientists have discovered in the past, are all listed on the periodic table of elements. And elements are special. The elements can combine in different ways and build up all the matter that you see. Remember last week we gave examples of matter. We said the tables, chairs, stationery, boiling water, this pen here, all this is matter. And all this matter is made of tiny particles called atoms. And those atoms belong to different elements. Now, these elements or atoms of different elements are able to combine. They're able to come together and form many other pure substances. But these pure substances are then called pure compounds. Remember, we said pure substances can be categorized or classified into two. Either a pure substance can be an element or they can be compounds. And all these elements, where do we find them? We find them on the periodic table. So we can have hydrogen combining with oxygen to give us a new compound, which is a pure substance. We can have carbon also combining with hydrogen and oxygen to give us a pure substance, and that pure substance is called a compound. It is called a compound. All right, now let's go back to the terminology. A pure substance, let's define it again. A pure substance is made up only of one element or one compound that cannot be separated into two or more substances by physical means such as distillation. So you can't break down, or you can't use distillation to separate a pure substance, or you cannot use crystallization or evaporation. Another method of separation is mechanical means. So you cannot use mechanical means either. Mechanical means such as sifting, so you can't sift to separate a pure substance. You cannot filter to separate a pure substance. You cannot use sorting to separate a pure substance. And you cannot use a magnet to separate a pure substance. So if you have a pure substance such as iron nails, you can't bring a magnet to try and separate. Okay. Now, a pure substance has chemical and physical properties that are constant throughout the whole entire sample. So if this pen is a pure substance, then its chemical properties and its physical properties are constant throughout the entire pen. So what does this mean? This means that in a pure substance will have a constant appearance, it will have a constant color, density, melting point, and boiling point throughout the whole sample. So the entire sample will have the same appearance, the same color, the same melting point, and the same boiling point. If we look at the first picture that I've just drawn up, water. So if this water is not mixed with any other substance, right, if it's pure, then this water will have the same color throughout. It's going to be colorless throughout. It will have the same density throughout. It will have the same melting point throughout and the same boiling point throughout. It's going to have a constant appearance. It's going to have a constant appearance. Same as these other pure substances that I have here, this gold bar, the silver bar, the palladium bar, and the copper bar. These bars are pure substances. These bars are pure substances. So what are some of these properties of pure substances? What makes something a pure substance? What makes it a pure substance? First of all, it's something called phase. It's something called phase. So when you want to find out what phase means, ask yourself, is the substance solid or liquid or a gas at room temperature? So the phase has to be the same throughout. If it is a solid at room temperature like a gold bar, it is going to be solid. The whole substance is going to be solid. For example, water. Water will be liquid at room temperature and oxygen will be a gas at room temperature. So the whole substance, or that whole substance that you have with you, should have one phase. Should have one phase. And then conductivity, you can also ask yourself, can the substance conduct electricity? Can the substance conduct electricity? Right. So some substances like copper are able to conduct electricity if they're in their purest form. Okay, and then we have water. Water comes in different phases depending on the temperature. If the temperature is very low, water will become a solid. If the temperature is room temperature, water will be a liquid. If the temperature is very high, water is going to be a gas. Now, solubility. Solubility is the substance soluble or insoluble in water. What does this word mean? The word soluble. So soluble means, can it dissolve in water? Take a glass full of water and a teaspoon of sugar. You pour the teaspoon of sugar into the water, then you stir. If the sugar dissolves completely, then it is soluble. If you take a teaspoon of millimil and you put it in a glass of water, if it doesn't dissolve, we say it is insoluble, which means it does not dissolve in the water. So solubility is also one of the properties of pure substances. And then density, does the substance float or sink in water? Does the substance float or sink in water? Then some more properties. Magnetism. Is the substance magnetic? I know for a fact pure iron nails are magnetic, so you can easily pick up iron filings or iron nails using a magnet, and you can simply pick it up from a mixture of different things. Okay, and then melting point. At what temperature does the substance melt or freeze? Boiling point. At what temperature does the substance boil or condense? So these are some of the properties that we refer to when we are talking about pure substances. Now we have arrived at our first activity. I'm going to read out the questions, give you time to answer, and then we'll go through the solutions together. The first question reads, what is a pure substance? What is a pure substance? The second question says, fill in the missing words. Blank and blank are examples of pure substances. And then for the third question, it reads, for each of the substances in the photographs below, decide whether it is a pure substance or a mixture. If it is a pure substance, decide whether it is an element or a compound. Give yourself 5 minutes to answer these questions. Then after 5 minutes, we will go through the solutions together. See you after 5 minutes. Welcome back, learners. So let's answer the questions together. Don't forget to send through your solutions to 079-578-2908. So what is a pure substance? This is a substance that is made up of only one type of atom or molecule. And then fill in the missing words. Blank and blank are examples of pure substances. Elements and compounds are examples of pure substances. Now, quickly copy down these two, question 1 and 2, and then in our next slide, we will answer question 3. So take 1 minute to copy down question 1 and 2 corrections. Welcome back, learners. So if you're going to contact our WhatsApp line, please do send a text and not a voice note. Please do send a text and not a voice note. Now let's answer question number 3. Right, so question 1, for each of the following photographs below, decide whether it is a pure substance or a mixture. If it is a pure substance, decide whether it is an element or a compound. Iron nails and muddy water. So iron nails, so this is a pure substance. So now we need to decide whether iron nails are made up of an element or a compound. This is an element because the iron nails are made purely of atoms that belong to one element, which is iron. And then we have muddy water. Muddy water is a mixture. It is a mixture of water and mud. Take 1 minute to quickly copy down this and then see you after 1 minute. Welcome back. Now let's tackle the last two pictures. So we've got sugar cube and iron sulfate. Are these two mixtures or are they pure substances? Sugar cubes, these are pure substances because it's just sugar cubes. Now, we have to decide, are they elements, under elements? Do they fall under elements or do they fall under compounds? Right, sugar cube is a compound made up of atoms of different elements. Remember, elements can combine with other elements to form compounds. So this particular compound is made of carbon, hydrogen, and oxygen. And then iron sulfate. Iron sulfate, this is a pure substance. It is a compound made of iron, sulfur, and oxygen. Iron, sulfur, and oxygen. Take 1 minute to quickly copy down the corrections, and then after 1 minute, we will continue with our lesson. Welcome back, learners. Let's continue with our lesson. Remember, our topic is pure substances and elements. So now let's tackle elements. Just a brief reminder. Remember, all known elements are found where? Yes, in the periodic table of elements. An element is a material that consists of atoms of only one kind. Can you give me examples of elements? We have hydrogen, that is the name of an element, carbon, sodium, and oxygen. So these are some examples of elements. You can send through examples of elements on our WhatsApp number. Remember, text your response. Do not send a voice note. Now, I have some more examples of elements. Gold is an element, silver, carbon, oxygen, and aluminium. We've often come across these elements in our day-to-day lives, like if you have gold jewelry, silver cutlery, or silver jewelry, the carbon that you use for your writing materials, the oxygen we breathe from the atmosphere, and aluminium cans and foil that we use at home. Alright, now what more can we learn? Now each element has unique properties, so they're not all the same. This is what sets them apart. This is what makes them different. Some elements can be molded into shape, while some elements, they are very brittle, meaning they easily break. Elements cannot be changed into another element either by physical means or through a chemical reaction. So you cannot change lithium into potassium. You cannot change helium into carbon. You cannot change one element into another. So that's another way elements in which elements are special. Now, elements have more than one atom, so you can have more than one atom of an element. For example, the element sodium. The chemical symbol is Na. Now, you can have one atom of sodium, which of course you cannot see with your naked eye. Remember from our previous lesson, we said we cannot see one atom or a singular atom with our naked eye. And then we can have more than one. We can have more than one. In this case, 1, 2, 3, 4, 5, 6. You can have more than one atom of an element. Okay, so in this example, there's only one element. So there's one element and there are different quantities of atoms of the element sodium. Okay, so you need to understand that we have the name of the element is sodium, but you can have many atoms that belong to the element sodium. Okay, now let's learn about diatomic elements. Now, some elements that we find on the periodic table, they are not made up of single atoms. They are made up of molecules. Remember, a molecule consists of a diatomic molecule consists of two identical atoms, and we call this a diatomic molecule. So if you have two atoms that are identical and chemically combined, what do you call it? It is a diatomic molecule. Now, diatomic elements, or rather elements that exist naturally as diatomic molecules, are found on the periodic table. We've got one here: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and arsenine. Now, these elements exist as diatomic molecules. So in nature, remember, these elements are found in nature. They are found all around us. They are found in nature, minus mine copper, minus mine iron, minus mine gold. So these elements are found in nature. So in nature, you find nitrogen as a diatomic molecule, which means you have two identical atoms that belong to the element nitrogen chemically combined together to form a diatomic molecule. Now, elements such as hydrogen, nitrogen, oxygen, chlorine, they cannot exist as individual atoms. Remember, so far we've been learning that an atom is the smallest building block of matter. Some of these building blocks in nature naturally cannot survive as individual atoms, and they can be found in pairs. So they pair up. They pair up and form what are called diatomic molecules in nature. So what do they look like after they've paired up? Hydrogen, those two atoms paired up. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So these are the elements that we need to remember, that we need to know exist as diatomic molecules in nature. So in nature, when that oxygen that you breathe in, it is a diatomic molecule. That hydrogen that is in the atmosphere, it is a diatomic molecule. Now, elements are able to form what are called compounds. Remember, we said pure substances can either be elements and can either be compounds. Now, elements are able to form what are called compounds. Now, sometimes atoms that belong to different elements react together chemically to form compounds. For example, you can take two hydrogen atoms and then they bond with one oxygen atom to form water. There we go. 2H, remember, is the symbol for hydrogen. 2 tells us that there are two hydrogen atoms, and then the O, there's 1. So two hydrogen atoms can bond with an oxygen atom to form water. What is water? A water is a molecule of a compound. It is a molecule of a compound because it is made of atoms that belong to different elements chemically bonded together. Now, which brings us to our second activity. Now, number 1. Use the periodic table below to give the symbols of the following elements. A, lithium. B, potassium. C, fluorine, and D, iron. Number 2. How are the atoms of one element different from the atoms of another element? Number 3. You need to get your pencils here. Draw models to show the atoms that make up the molecules below. Water, hydrogen, and oxygen. Water, hydrogen, and oxygen. So I'm going to give you 5 minutes to do this activity, and then after 5 minutes, we will do the corrections together. See you after 5 minutes.
Welcome back, grade 8 learners. Now let's answer the questions together. So the first question read, use the periodic table below to give symbols for the following elements. So the first one is lithium. Where is lithium? Lithium is right there. Right there, it is Li. The second one is potassium. Potassium is represented by the chemical symbol K. And then the third one is fluorine. Fluorine is right there with the non-metals. It is represented by the symbol F. And then ion is Fe, which is there with the metals, which is represented by the letters, this chemical symbol Fe. Question 2. How are atoms of one element different from another element? Atoms of different elements have different numbers of protons, neutrons, and electrons. So take 1 minute to copy down these corrections and then we'll answer number 3 together. Welcome back, learners. Now let's answer the third question together. We're supposed to draw models to show the atoms that make up molecules: water, hydrogen, and oxygen. So the first one, water. Remember, we said water is made up of two hydrogen atoms and one oxygen atom. And then hydrogen exists naturally as a diatomic molecule. So we have two hydrogen atoms. And then oxygen exists naturally as a diatomic molecule. So we have two of those as well. Now take 2 minutes to quickly copy down these drawings. And after 2 minutes, we will wrap up our lesson. Welcome back, learners. Now let us wrap up our lesson. What did we learn today? we learned about pure substances and that pure substances are made up of only one type of atom or molecule or compound. We also learned that elements, these are substances that cannot be broken down into two or more substances by chemical means. We also learned that elements are made up of atoms of only one kind. Then there are some elements that exist naturally as diatomic molecules, which are two atoms that are chemically bonded together. We gave examples of hydrogen, oxygen, fluorine, chlorine, and iodine. And sometimes elements of different elements, right? Atoms of different elements chemically combine to form compounds or molecules of compounds. Okay, grade 8 learners, next we have our homework. So here are the two questions. Quickly grab your pencils and books and copy them down. I'm giving you 2 minutes to copy down the homework assignment. Then after 2 minutes, we will end our lesson. So see you after 2 minutes. Welcome back, learners. Now, thank you so much for joining me in today's lesson. Our next lesson is going to be compounds. So, grade 8, bye-bye.